From the dawn of human consciousness, we have gazed at the stars and pondered the vast mysteries of the cosmos. The night sky, with its twinkling stars and infinite expanse, has always been a source of wonder and curiosity. It has inspired countless myths, legends, and scientific inquiries, driving humanity to seek answers to the fundamental questions of our existence. Yet, perhaps no concept has captivated our imaginations more than the idea of time travel. The ability to journey through the annals of history or leap forward into the uncharted territories of the future. This notion has been a cornerstone of countless stories, from ancient myths to modern science fiction, each exploring the tantalizing possibilities and profound implications of traversing the timeline. It is a concept deeply ingrained in our cultural consciousness, inspiring countless works of science fiction and fueling our innate desire to transcend the limitations of our temporal existence. From H.G. Wells' The Time Machine to the blockbuster Back to the Future series, time travel has been a fertile ground for exploring human nature, ethics, and the consequences of our actions. Imagine standing alongside Julius Caesar as he conquers Gaul, witnessing the strategies and decisions that shaped the course of history. The ability to observe pivotal moments firsthand would offer unparalleled insights into the events that have defined our world, or witnessing firsthand the birth of the first star in the universe, a moment that marked the beginning of the cosmic dance that continues to this day. Such experiences would not only deepen our understanding of the universe, but also our place within it. Time travel, if achievable, would not only satiate our thirst for knowledge, but also fundamentally alter our understanding of history, destiny, and the very fabric of reality itself. It would challenge our perceptions of cause and effect and force us to reconsider the nature of time and existence. But the tantalizing prospect of time travel is not without its challenges. The very idea of moving through time presents a host of scientific and philosophical dilemmas. How would we navigate the paradoxes that arise, such as the infamous grandfather paradox, where altering the past could prevent one's own existence? For decades, scientists and philosophers have grappled with the mind-boggling paradoxes and logical inconsistencies that arise when we contemplate manipulating the river of time. Theoretical physicists have proposed various models, from wormholes to quantum mechanics, each offering a glimpse into the potential mechanics of time travel. Is time travel merely a fantastical notion confined to the realm of imagination, or could it one day become a tangible reality? As our understanding of the universe deepens, the line between science fiction and science fact continues to blur, leaving us to wonder what future discoveries may hold. Let us embark on a journey to explore the intriguing intersection of time travel, mathematics, and the fundamental laws that govern our universe. Together, we will delve into the theories, the possibilities, and the profound questions that time travel raises, seeking to understand not just if we can travel through time, but what it would mean for humanity if we could. The most enduring and perplexing challenge in the realm of time travel is undoubtedly the infamous grandfather paradox. This paradox has fascinated scientists, philosophers, and science fiction enthusiasts alike for decades, as it delves into the very fabric of our understanding of time and causality. This thought experiment, a staple in any discussion on time travel, exposes a fundamental incongruity that arises when we consider altering the past. It challenges our perception of a linear timeline, suggesting that any change in the past could have profound and unpredictable effects on the present and future. Imagine, if you will, a scenario where you, a daring time traveler, journey back in time to a period before your parents were born. The very act of traveling to the past opens up a myriad of possibilities and potential consequences that are both intriguing and terrifying. In a twist of fate, you encounter your grandfather and, driven by an unknown impulse, prevent him from meeting your grandmother. This seemingly simple action sets off a chain reaction that could alter the course of history in ways you cannot even begin to imagine. The paradox lies in the immediate consequence of this action. By preventing your grandparents from meeting, you effectively erase your own existence. This creates a logical conundrum. If you were never born, how could you have traveled back in time to prevent their meeting in the first place? By preventing your grandparents from meeting, you effectively erase your own existence. This paradox is not just a theoretical puzzle. It has profound implications for our understanding of time, causality, and the nature of reality itself. After all, if your parents were never born, how could you, their offspring, exist to travel back in time in the first place? This question has led to numerous theories and interpretations, ranging from the idea of parallel universes to the concept of a self-healing timeline that corrects any paradoxes. This paradox highlights the inherent contradiction of altering the past within a linear understanding of time. It forces us to reconsider our assumptions about the nature of time and whether it is truly possible to change the past without creating irreparable damage to the timeline. If the past can be changed, it creates a ripple effect that unravels the very foundation of the present and future as we know it. The grandfather paradox serves as a powerful reminder of the complexities and potential dangers of time travel, urging us to tread carefully as we explore the mysteries of the fourth dimension. The grandfather paradox isn't just a mind-bending thought experiment, it underscores a fundamental principle that underpins our understanding of the universe: causality. Imagine for a moment you travel back in time and inadvertently prevent your grandfather from meeting your grandmother. The very act of your existence would be called into question. This paradox highlights the delicate balance of cause and effect that governs our reality. Causality dictates that every effect must have a cause, and that these causes precede their effects in the relentless march of time. This principle is not just a philosophical idea, but a cornerstone of scientific inquiry. From the simplest chemical reactions to the most complex biological processes, causality ensures that the universe operates in a predictable and orderly manner. In essence, causality is the invisible glue that holds the fabric of our reality together. It is the reason why we can trust that the sun will rise tomorrow, why we can predict the changing of the seasons, and why we can rely on the laws of physics to remain consistent. Without causality, the universe would be a chaotic and unpredictable place. It ensures that events unfold in a logical and consistent sequence, preventing utter chaos and temporal anarchy. Imagine a world where the past, present, and future were constantly shifting and changing. Such a world would be incomprehensible and uninhabitable. Causality provides the structure and order that make life as we know it possible. Time travel, at least in its classical conception, throws a wrench into this elegant machinery. The idea of moving freely through time, altering events and reshaping history is a tantalizing concept, but it comes with significant consequences. If we could change the past, we would disrupt the very fabric of reality, creating paradoxes and inconsistencies that could unravel the universe itself. If we can travel back in time and alter past events, we violate the fundamental principle that the past influences the present, not the other way around. This violation of causality would have far-reaching implications, not just for our understanding of time, but for the entire framework of physics. The laws that govern the universe are built on the foundation of cause and effect, and tampering with this foundation could have catastrophic results. The very act of changing the past would create a causal loop where the effect, your action in the past, precedes the cause, your existence. This loop would create a paradox that defies logic and reason. It challenges our understanding of time and raises profound questions about the nature of reality. How can an effect exist before its cause? How can the future influence the past? These are questions that remain unanswered and continue to baffle scientists and philosophers alike. This violation of causality isn't just a theoretical concern, it has profound implications for our understanding of physics. If causality can be broken, then the laws of physics as we know them could crumble, leading to a universe where predictability and order are replaced by utter randomness and chaos. The very foundations of science would be shaken, and our ability to understand and navigate the world would be severely compromised. If causality can be broken, then the laws of physics as we know them could crumble, leading to a universe where predictability and order are replaced by utter randomness and chaos. The implications of such a scenario are staggering. It would mean the end of scientific inquiry as we know it, the collapse of technological progress, and the unraveling of the very fabric of reality. The unseen barrier to time travel is not just a theoretical construct. It is a fundamental principle that safeguards the order and stability of the universe. While the challenges posed by the grandfather paradox and the principle of causality seem insurmountable, recent breakthroughs in theoretical physics offer a glimmer of hope for aspiring time travelers. A new mathematical framework, inspired by the seemingly unrelated field of random walks, suggests that time travel might be possible without violating the sacred laws of causality. This new approach, instead of viewing time as a rigid linear progression, envisions it as a more fluid and multidimensional landscape. Imagine time not as a straight line but as a winding river, meandering through the vast cosmos. Within this river, there may be hidden eddies and currents, shortcuts that could allow us to navigate upstream seemingly against the relentless flow of time. The key to understanding this new perspective lies in the concept of random walks, a mathematical model used to describe the unpredictable path of a particle as it moves through space. Surprisingly, this concept, often applied to microscopic particles, might hold the key to unlocking macroscopic time travel.